Hello, hi everyone, and welcome to the stream by OneClass. My name is Nehel, and today we'll be solving math questions. Just a little bit about myself. I graduated from University of Waterloo in 2018. I went there to study mechanical engineering, and as part of the course, I completed 6 co-op terms and have been working in the plastics industry for the past 2 years. Next step for me is that I'll be starting my master's degree at U of T in about a week. So I'm looking forward to that. So the math questions we'll be covering will be of high school to university level questions, and some might be a bit junior questions as well. And we'll be covering, this will be a half-hour stream, so we'll be covering about 5 to 6 questions. All right, let's jump into and solve some math questions. So first up, we have a trigonometry question, which is asking us to prove that tan x over 1 plus secant x is plus 1 over 1 plus secant x over tan x is equal to 2 cosecant x. So with any proof like this, we can start from either the left-hand side or the right-hand side. In our case, we will start from the left-hand side. So let me just copy this over. Okay. So I'm going to start from the left-hand side, but before I do start, I want you guys to note a trigonometric identity, which will likely be handy for this question. That identity is, and I'm going to mark that down as a thin cloud. So keep in mind that tan square x plus 1 is equal to secant square x. So this is just as a side note. We will likely be needing this identity or in some shape or form for this question. So starting from the left hand side, so we have 2 fractional terms and they're being added. So I'm gonna go ahead and add them. So since their denominators are not the same, we would have to multiply their denominators with their numerators. So the opposite denominator with the numerator. So we would get tan square x plus 1 plus secant x whole squared over 1 plus secant x times tan x. Okay, all we've done is we've gone ahead and added the 2 fractional terms together. Over here we see that we have whole squared terms, so we can go ahead and expand this. So for that we will get tan square x plus 1 plus secant square x plus 2 secant x whole over 1 plus secant x multiplied by tan x. Okay, at this stage, what I can see is that I have a denominator which is full of secant x and tan x, and I would likely need to take out something common from the numerator so that it gets cancelled with the denominator. So it can either be tan x or it can either be 1 plus secant x. I don't know at this stage, but what I will go ahead and do is I will go ahead and replace this. So if you see here, this looks oddly familiar, or this looks exactly like our thin cloud. This is actually nothing but secant square x. So we'll go ahead and plug that in. We would get secant square x plus secant square x plus 2 secant x whole divided by 1 plus secant x tan x. On the top we have 2 similar terms, so we'll go ahead and add them, and we would get 2 secant square x plus 2 secant x whole divided by 1 plus secant x tan x. Okay. From the numerator we see that we have 2 secant x terms, so we can take secant x as common, and we can actually take the number 2 common as well. So if we take 2 secant x common, you would get secant x plus 1 divided by 1 plus secant x times tan x. These two terms in the numerator and denominator, secant x plus 1, are common. So we can go ahead and cancel each other out. So far we're left with 2 secant x over tan x. Now secant x is nothing but 1 over cos x, and tan x is nothing but sin x over cos x. So secant x is 1 over cos x, and tan x is nothing but sin x over cos x. Okay, so knowing that, we will plug these two into this, and we would get 2 times 1 over cos of x whole divided by sin of x divided by cos of x. So in this case, the cosines of x get cancelled out, and we're left with 2 over sin of x. Okay, which if we do recall, we know that, which is another think cloud thing to know, and these are trigonometric identities which we would need to know in order to solve this question, that 1 over sin x is equals to cosec x. So this is another think cloud thing to know. Therefore, we get 2 cosec x as the final term, which is equals to the right hand side. So that concludes the proof. We have been able to prove that tan x over 1 plus secant x plus 1 plus secant x over tan x is indeed equal to 2 cosecant x. So we can say hence proved. Alright, let's verify that the solution is correct as well. So that's correct, and then we add these two, then we get this, then we substitute. So the way they've written this equation is actually incorrect, because at this stage this equation translates to tan square x is equals to 1 plus cosec square sec square x. So that's incorrect. So even though it looks like they got the correct answer, the equation that they have identified is marked incorrectly. So I'm gonna point that out. So the final answer of the proof is correct. However, the identity stated is has an error. It should be tan, let's just say tan x squared plus 1 is equals to secant x squared. Okay, so I'm gonna go ahead and mark this question as incorrect for the time being. Okay, so just this should be the identity which we use. So I'm gonna say solution is incorrect. Question number 2. So we have been asked to carry forward a series of questions. These are all mostly trigonometric based. So we'll go ahead and start with part number 1. So part A is that show that sine 30 plus theta is equals to 1 over 2 cos theta plus under root 3 over 2 sine theta. So in order to do this question, we would need a few things as part of the think cloud again. So number 1 would be the sine x plus y identity. So I'm going to write that down. So sine x plus y is equals to sine x cos y plus cos x sine y. Okay, furthermore, we would need to know two trigonometric terms which we can get from the unit circle, or if you do recall, they would be sine of 30 is equal to 1 over 2 and cosine of 30 is equals to under root 3 over 2. So these are all part of the thin cloud. We will use these to solve the given question. So right at the back, we know that the left hand side, we can use the first identity which we have noted down. Here x is equals to 30 degrees and y is equals to theta. So based on that, we can say that sine 30 plus theta is nothing but sine 30 cos theta plus cos 30 sine theta. And now, given the knowledge of the values of these two terms, we can say sine 30 is nothing but 1 over 2. Thing as part of the thin cloud we would have is the tan value of these terms. So tan of pi over, get these from the unit term, unit circle, or if you do recall them, tan pi over 4 is 1 and tan pi over 6 is root 3 over. So I'm going to enclose these terms in the thin cloud so we have them ready when we need to use them. 12, which is equals to tan of pi over 6 under root 3. The reason we're doing this is every time we have square root term in the denominator, we can go ahead and use this trick. 3 whole square minus 9 minus 3. So essentially it's 3 square minus under root 3 square, which is equals to 3 plus under root 3 squared over 9 minus 3, which is 6. So that is the final answer. Okay, so next up, we have been asked to use half angle formula to show that cos of pi over 8 or cos of pi over 8 is equal to this value. So this will be number C. So show that cos of pi over 8 is equals to okay. So in order to do this question, we would again need a few things in our thin cloud. The first one would be the half angle formula. So the half angle formula says that cos of x over 2 is equals to plus minus under root of 1 plus cos x over 2. And then furthermore, it will be handy to know that cos of pi over 4 is equals to under root 2 over 2. So again, I'm going to enclose this in my thin cloud. This is essentially is not part of the solution, but we will need this to get to the solution. So looking at this term, and we've been asked to use the half angle formula, we can say that x is equals to pi over 4. Therefore, we can say cos of 1 over 2 times pi over 4. So this is essentially x over 2 is equals to square root of 1 plus cos pi over 4 divided by 2. Okay. And then if we continue to evaluate the right hand side, we know that cos of pi over 4 is root 2 over 2. So we get 1 plus square root of 2 divided by 2 plus 2 is equals to 2 plus square root of 2 divided by 2 times 2, which is 4. And since 4 is a complete whole square of 2, or a complete square, we can take it out of the big square root. And we're left with square root of 2 plus under root 2 whole divided by 10, which is equal to the right hand side. Hence proved. Okay, so that was the proof of the third question. And then the final question, D, we are asked to evaluate a few trigonometric inverses. So A is arc cos sine pi over 6. So if you're not familiar with this notation, this is essentially saying cos inverse of sine pi over 6. Okay, so sine pi over 6, or sine 30 degrees, is equal to 1 over 2. So we substitute that here, and cos inverse 1 over 2 is equal to 60 degrees, so that's pi over 3. Important thing to note here is that when the final answer is in terms of or the final function is inverse function, inverse trigonometric function, your answer would be an angle. So in this case, our answer is pi over 3, or 60 degrees. Okay, and for the second part, tan inverse of cos pi over 2. We know that cos of pi over 2 is actually 0. So we get tan inverse of 0. Tan is 0 when sine is 0, which is 0 at 0 degrees. Therefore, this is equal to 0. Okay, so those should be all the answers. Let's make sure. So for the first one, they've used the angle sum identity for 30 degrees. That's correct. So the first question is correct. For the second question, they've used their tan angle sum identity again. Therefore, they simplified it. So instead of just leaving it as the whole square, they have gone ahead and squared it. So that's correct. For the third part, they were able to prove it using cos pi over 4 for the half angle rule. So that's also correct. And then finally, for the inverse questions, pi over 2, pi over 3, that's correct, and then 0 degrees. So these are all correct. All the solutions are correct. Okay, let's get into the third question. How do you write 0.4 as a fraction in simplest form? So every time you have a decimal point, you have to count the number of decimals and multiply that by the number of zeros in a 10. So, or 10 to the power of that many. So let's say in this case, we have 0.4. And there is one decimal place behind, or one number behind the decimal place. So in order to simplify it further, what we can do is we can multiply it by 10 to the power of 1, or divide it by 10 to the power of 1. So if there were two decimal places, we would multiply and divide this by 10 to the power of 2, and so on. But in this case, since there's this one decimal place, we are multiplying and dividing it by 10 to the power of 1. This gives us 4 over 10. Yeah. And then we know that 4 and 10 have a common multiple, which is 2. So 2 times 2 is 4, and 2 times 5 is 10. This implies we're left with 2 over 5 as the simplest form. Okay, so perfect, this answer is correct. So just to note here, as I said, you count the number of decimal places you have. You multiply it and divide it by 10 raised to the power of number of decimal places. So in this question, we only have one decimal place. And then you further simplify looking at the common multiples to get your simplest fraction form. Question number 4. So we're given an identity to verify. Again, this is one of those questions which we would need think cloud for in order to identify or in order to use already defined identities. Okay, so in this question we have sine 2x and cos 2x. So we will prove from the left hand side, but let me go ahead and write some identities which we likely need. So we know that sine squared x plus cos squared x is equals to 1. And we also know that sine of 2x is equals to 2 sine x cos x. And then cosine of 2x is equals to cos square x minus sine square x. Okay, so I'm going to mark this down as my think cloud again, and then I'm going to go ahead and look at the left hand side. I see that I have sine 2x, which I need to further simplify in a single angle. I have cos 2x, which I need to further simplify as well. But once I'm done further simplifying those, I'll be left with a combination of sines and coses with a 1, which is of no real help. So I'm going to simplify 1 as well while we're at it. So we're going to get sine square x plus cos square x, which is 1, minus, and sine 2x becomes 2 sine x cos x, divided by cos 2x becomes cos square x minus sine square x. Now if we further investigate, further look into this, on the numerator side we have form a square plus b square minus 2ab, which is equal to a minus b whole squared. So in this case, a is sine x and b is cos x. So we will go ahead and write this as sine x minus cos x whole squared divided by, and for the denominator, if we look carefully, we know that a square minus b squared is equals to a plus b multiplied by a minus b. So we can write the denominator in a simplified form as well, where a is cos x and b is sin x. So we're left with cos x minus sin x, cos x plus sin x. Now if you look here, even though these terms are not identical, what we can do is we can take a -1 common from the numerator, and since it's squared, we will be left with the same term. So essentially, what I'm saying is that cos x minus sin x squared is equals to sin x minus cos x squared. So using that, I'm going to switch this to cos x minus sin x squared. Divide that by cos x minus sin x cos x plus sin x, and then this term and the numerator term are the exact same. Numerator is of the power 2, so we deduct one power, and we're left with cos x minus sin x over cos x plus sin x, which is nothing but equal to the right hand side. Therefore, hence prove that LHS is equal to RHS. Okay, let's just make sure that that's indeed the solution. We're using these identities, that's perfect. We substitute 1, we substitute 2 sin x cos x, perfect, perfect. Thus using the LHS. Okay, so the answer is correct. Okay, this actually brings us to the end of today's stream. I hope you found this of some value. If you did, please feel free to like, comment, and subscribe. If you do have any questions, you can ask them in the comment section, or you can check the description below the video, and you can join us at OneClass, and we'll be happy to help you. Thank you so much, and have a great day. Bye-bye.